Okay, my people, let's quickly take a close look at what we are discussing. Physics 102 is the course. Second semester physics, electromagnetism. And we are still on electrostatics. We have discussed the special cases of Coulomb's law, and now we are solving problems, okay? Class, take a look at what they have here. They say find force on Q2. Find the force on Q2. Where is Q2 located? Let's do that together. This is Q2. This is Q1. This is Q3. Now, if somebody says you should find the force on Q2, what it means is resultant force on Q2, because this is a system of charges. There are 3 charges as a matter of fact. Q1, Q2, Q3. Is that okay? There is a force that Q1 will exert on Q2. There is a force that Q3 will exert on Q2. The resultant of the 2 forces will produce the resultant force on Q2 as demanded by the question. Okay? So let us start. The first thing we are going to do is to get the force exerted on charge 2 due to charge 1. Check out the way I wrote that. Force on 2 due to 1, F2, 1. According to Coulomb's law, it will be K, Q1, Q2, because we're talking about 2 and 1, all over the distance separating them, raised to power 2. You make your substitutions. K is a constant. The value is 9 times 10 raised to power 9. Q1, you go to your diagram. This is Q1. You have minus 2 microcoulombs. Let me announce to you that in this Coulomb's formula, what we represent here is the magnitude of the charge, the modulus. So you don't assign minus here. I'm going to teach you how we're going to take care of this minus here. Just follow me. So in as much as what I have here is minus 2 microcoulomb, in this formula, what I'm going to introduce is 2 microcoulomb. So I will write 2 times, I need to convert the 2 to coulomb. From microcoulomb to coulomb, what do? You multiply by 10 raised to the power of minus 6. Times, we go to Q1, Q2. What's the value of Q2? 3 microcoulomb. So you say 3 times 10 raised to power minus 6. Converting from microcoulomb to coulomb. All over the square of the distance separating 1 and 2. So what would that give us? That is 4 square. 4 square. The distance is 4. Is that okay? So let's simplify. I will have 9 times 2 times 3. 9 times 2 is 18. Is that what we have there? So let's write that out. 9 times 2 times 3 times 10, 10, 10. They have the same base. So what do we do by law of indices? I will take one of the bases and add the powers. 9 minus 6 is minus 3 is 3. 3 minus 6 will give us minus 3. All over 4 square, which is 16. 2 cancel itself. 1 cancel 16. What do you have? 8. So follow me. 9 times 3 is 27 over 8 times 10 raised to power minus 3. So let's solve the maths. I've got my calculator here. So let's go there. 27 divided by 8. That is 3.375. 3.375 times 10 raised to power minus 3 in Newton. Remember, it's force, so the unit is Newton. So class, what have I gotten now? I have gotten the force that will be exerted on 2 due to 1. So let me write that out somewhere. So the first one, I'm going to call that force on 2 due to 1. Our result is what? 3.375 times 10 raised to the power of minus 3 Newton. Okay, so the next thing we are going to do now is to get the force on the same 2 due to 3 this time around. Because the question is, find force on 2. Find the force on 2. I told you, there's a certain amount of force that will be exerted on 2 by 1. There's a certain amount of force that will be exerted on the same 2 by 3. Having found the force on 2 due to 1, my people, now let us move ahead and get the force on 2 due to 3. Follow me. Follow me. We are going to the Tomankasa proper. Ngwa now. First class honors is not for everybody. After all, stand up for Jesus. The cripple may not be involved. It's for the decimal part of the students that are very serious. What's the next gist? Let's get the force on the same 2, but due to who now? 3. Check out the way I wrote it. F2, 3. That means force on 2 due to 3. My people, what is it going to be? K, Q2, Q3. You know why? I'm talking about 2 and 3 now. All over R squared. Let's substitute. Let's be very fast. What's K? You're beginning to mature in the topic. So what's K? 9 times 10 raised to power 9. It's a constant. Q2. Look at the value here. Plus 3 microcoulomb. But remember, you need to convert from microcoulomb to coulomb by multiplying by 10 raised to power minus 6. So that's going to be 3 times 10 raised to power minus 6 times Q3. Class, watch. See Q3, that is 9 microcoulombs. So I will say 9 times 10 raised to power minus 6 all over. The distance between Q2 and Q3 is given here as 3. So I'm going to write 3 square. Job has finished though. Do you know that 3 square is 9? So 3 square, which is 9, we'll cancel this 9 here. What do I have left? 3 times 9, 27 times 10. Take one of the bases. We'll add the powers. 9 minus 6 is 3. 3 minus 6 is minus 3. So what's the result? 27 times 10 raised to power minus 3 in Newton. I have gotten the force on 2 due to 3. Earlier I got force on 2 due to 1. Ngwa. Follow me. So I can wipe the question now. I've gotten all that I need. I've gotten everything I need. What are the things I have, my people? 1. I have the force on 2 due to 1. What is the result? 3.375 times 10 raised to power minus 3 Newton. Next, force on 2 due to 3. What did we get? Force on 2 due to 3. We got that as what again? That is 27 times 10 raised to power minus 3 Newton. Alright, let's go there. The next thing we are going to do now is to check the directions of those 2 forces. That means I need the diagram again. Remember that in the diagram, they said this is Q1, Q2, Q3. Remember? The charge here is minus 2 microcoulomb. This is plus 3 microcoulomb. And this is plus 9 microcoulomb. Okay, now my people, I need the directions of the 2 forces so I can know how to get the resultant. Remember that when 2 forces are in the same direction, 2 vectors, force is a vector quantity. So when 2 vectors, 2 forces are in the same direction, 2 parallel vectors in the same direction, what do? We get the resultant by adding in the same direction. But if you have 2 forces that are in opposite direction, 2 parallel forces in opposite direction, how do you get the resultant? By subtraction. You subtract the small one from the big one, and the resultant is in the direction of the bigger force. So, I need the direction of F2, 1, force on 2 due to 1. I need the direction of force on 2 due to 3. It's when I know their directions, I will now know whether to add them or subtract them to get the resultant. I hope it's making sense. Now follow me. My people, this charge here is negative. It's negatively charged. but this one is positively charged. I'm looking at the direction of force on 2 due to 1. What should be the direction? Let's reason. Now let me give you a simple code. We call it code to decode decoder. Shortcut. When you have two opposite charges, one is negative, one is positive, you know there should be attraction. Now the rule says the force of attraction is in the direction of the bigger charge. I take it again. The force of attraction is in the direction of the bigger charge. If two charges, one is positive, the other one is negative, and they want to attract each other, it is the big one that will pull the small one towards itself. And that's why we say that the force of attraction is in the direction of the bigger charge. So this is plus 3, this is minus 2. The bigger charge is Q2. And since its force of attraction that is taking place here is going to be the direction of the bigger charge, which is Q2. That means force on 2 due to 1 should be in this direction. Physical to mankasa. Now the next thing will be, what should be the direction of force on 2 due to 3? Class, watch you. 2 and 3, C2, C3. This is positive, this is also positive. So they are like charges, which means they are supposed to repel. Now, the force of repulsion, listen to this code. The force of repulsion is in the direction of the small charge. If you have one big charge and a small charge, and they want to push each other apart, it is the big one that will push the small one in the direction of that small one to just do it like this. Like this. So, the force of repulsion is in the direction of the smaller charge. So if I have Q2 and Q3 that are supposed to repel each other because they carry similar charges, the force of repulsion will be in the direction of the smaller charge, which is plus 3 microcoulomb. That means it's going to be like this, towards Q2. My people, what it means is that the two forces have opposite directions. So the resultant will be gotten by subtraction. So the force on 2 will be, it will be force on 2 due to 3, which is bigger, minus force on 2 due to 1. Let's do that together. That is 27 times 10 raised to power minus 3 minus 3.375 times 10 raised to power minus 3. Check it out. There is something common. 10 raised to power minus 3 is common. So what do? I can factorize. That will be 27 minus 3.375 all in bracket 10 raised to the power of minus 3. So let's see what it gives us. Follow me. Let's subtract. 27 minus 3.375. The result is 23.625. Then times 10 raised to the power minus 3. Please tell them that you're a professional by putting this in standard form. That will be 2.3625 times 10 raised to power, supposed to be raised to power 1. Then that 1 minus 3 is now minus 2 Newton. Whoa! Physics is just too delicious. They give you physics and give you 20 billion naira. Which one do you take? I'm sure you're going to rush physics. Too delicious. Please absorb, digest, and assimilate while I return your way shortly. My name is Bookish. Enjoy!